Hello everyone. So now we will continue with the next example for the goodness of fit test. Okay, so it is claimed that the frequency distribution of the lifetime of a certain brand and model of a car battery, okay, so just like in GRQ, Mutlu Q, something like that, may be approximated by a normal distribution with mean mu is equal to 3.5 years and standard deviation sigma equal to 0.7 years. Well, let's test this by using the chi-square goodness of fit test. So a random sample of 40 batteries were followed in their lifetimes, which is the duration from initial installment time until they fail, were recorded. So what they do is they just install a battery, and then after the battery fails, they just measure the time between the installment and the failure. So this time is the lifetime of that battery, right? So this is what we have. Right? So between 145 and 195, you have two batteries. Which what does this mean? It means that well, but the lifetime of two batteries are between 145 years and 195 years. One battery, the lifetime of one battery is between 195 and 245 years. The lifetime of a battery, the lifetime of four batteries are between 245 and 295, and so on and so forth, right? So this is just like, so if you just use this, you can just plot the histogram, right? So you have, let's say this is 1.5, this is, let's say, 2. It's not exactly 2, but okay, let's take it as it is. 2.53, 3.54, this is 4.5, and that's at plus I, sorry. At plus I have the 5. So between 145 and I have two batteries here, okay, one battery here, and I have four batteries here, and then 15 batteries, which is very large, okay, just like this. I have 15 batteries, and then 10 batteries, okay. And then I have 5 batteries, plus I have 3 batteries, okay? Right? So when you just look at the histogram, well, it looks like the normal distribution, okay? But of course, by just visual inspection, you cannot directly say that it's normal. It looks like normal, but now we will, using a mathematical hypothesis test, we will try to see whether it is really normal or not. Okay? So let's say the hypothesis, the null hypothesis says that the data come from a normal distribution with these parameters. H1 is, well, the data does not come from this distribution. I don't know its distribution, but it's not this one. Okay? So, well, the data shows the observed frequencies, okay, for n is equal to 40. So what we need, so these are OIs, right? I have the OIs, but in order to calculate, remember, I have chi-squared, I will just calculate this, chi-squared OI minus EI squared divided by EI. So what I need is the expected frequencies, okay? Okay. So a rule of thumb is that the test becomes better, which means more sensitive when we combine the intervals with small frequency so that the expected frequency will be at least 5. Okay, so what does this mean? So having 2, 1, or 4 is not preferable, let's say. What we do is we just merge them. 2 plus 1, 3. That's not good as well. So what we do is we just merge these 3, which is equal to 7 observations between what? So I will have 145 and 295. Okay? This is nice. This is nice. This is nice, but this is not nice. What I do is I just merge them, so I have 80. Okay. So in the end, what I have is I have this 1, 2, 3 blocks. Okay. Okay. So so let's try to find the expected frequencies, okay? Expected frequencies. So how to find the expected frequencies? Remember, in the previous part, in the previous question, how we just calculate this? We first find the probability So in the previous question, the probability was 1/6 times, we just multiply it by n, the number of observations, okay, the number of observations or experiments, right? So now what is the number of observations in this example? That's equal to 40, okay? Now we need the probability. What is the, which probability? So the probability that you have, what is the probability that a car battery's lifetime of a car battery is between 2.95 and 345. Okay, this is the probability that I have. So the probability is, what is the probability that the lifetime of a battery is between 295 and 345. Okay, so how to find this probability? Well, so we assume that H raised true, right? H raised true. So remember, how do we just make the hypothesis testing? We assume that H raised true. So if H raised true, then X, the battery life is normally distributed with 3.5 years, and I forget sigma, but let me just check, 0.7 years, okay? 0.7 years. This is the probability distribution. Now this one just asks, what is the probability that your X is between 295, right, and 345? That's as easy as it is. Okay? So what is the probability that your battery's lifetime is between 295 and 345? Just convert this to standard normal. 295 minus 3.5 divided by 0.7, x minus 3.5 divided by 0.7. What is this? This is z, right? This is also smaller than 3.45 minus 3.5 divided by 0.7. Okay, so this is the probability of this is the probability that lifetime of a car battery is between 295 and 345. So what is this probability? That's equal to 0.2555. Okay, so this is the probability that your lifetime of a car battery is between 295 and 345. Okay, so the next step is just multiply it by 40. Okay, and it turns out that this is equal to 10.2204. So generally, we just omit the rest of the digitals except the first digital. So the expected frequency turns out to be 10.2. Okay, so this is my expected frequency. Okay, so for the third class, again, we will calculate the probability that X is between 345 and 395, which is equal to 0.2683. And here the expected value is again 10.7. Okay, so just go back. So here I have 10.2, this is my expected value, and 10.7, this is my expected. Okay, so what I need is to find the rest of the expected values. So in order to find the, so remember this was 145 and 295, right? And this is, in fact, this part is 3.95 and 4.95. Okay, so I will try to calculate the probabilities regarding the first and the last bucket, let's say. So this is somewhat different. Why? So what I will do is, so just think of this. What if I just remove this left part and just write minus infinity to here and say that, well, my first bucket is the batteries, the lifetime of the batteries whose length, whose lifetime is smaller than 2.95, which means, in fact, the bucket is between minus infinity and 2.95. Okay? So, in fact, this bucket is, let's say, the lifetime which is smaller than 2.95. Okay? So, this is my bucket. And for the last bucket, similarly, I will just change this to from 3.95, 4.95. I will just write this. This bucket is greater than 3.95. Okay. So there will be no change because there are no batteries whose lifetime is greater than 4.95. Okay. So if you just say, well, this is the bucket, this is the bucket, this is the interval where the lifetime of the batteries are larger than 3.95 years, or more legitimately, you can just say this is 3.95 and plus infinity. Okay. Then, how do we calculate the probability here? The probability here is that the probability x is greater than 3.95. And how about the probability here? The probability here is the probability that x is smaller than 2.95. Okay. So let's calculate those probabilities as well. Okay. So the probability that x is smaller than 2.95, that's equal to 0.216. And this is my expected value for the first one. And this is the probability for the last bucket. And this is E4, not E1, but this is E4. That's equal to 10.4. Okay, so the expected values, the summation of them is equal to 40, right? This is what I expected, right? This is intuition. This is, for the first one, remember, so for the first one, I have 10.2, okay? That equals 10.2, so 8.7 in the first bucket. This is the first bucket. This is the second bucket. This is the third bucket. And 10.4 is the last bucket. So I have what? I have n equal to 40. So what I expect is to see summation of these four should be equal to 40. Okay, and that's what I have. Okay, that's great. So these are the expected values, and these are the observed values. Okay, and what's next? The next step is to calculate the chi-square, okay, the observed chi-square. So this is equal to, again, what is this? 7.8.7 squared divided by 8.7 plus dot, dot, dot. It goes like this. You have four summations there. Well, since the degrees of freedom 3 is 3 because you have what? You have four observations, and let's try to calculate, find the result of the hypothesis using alpha equal to 0.05, that significance level. Well, it turns out that the chi-square observed is equal to 3.15. Okay, and how about the chi-square critical? The chi-square critical, which leaves an area of 0.05 to the right at 3 degrees of freedom, is 7.815, well, which is greater than 3.15. Okay, so this is my chi-square observed. So what does this mean? Well, we don't reject H0. What does it mean not rejecting H0? Well, it turns out that the probability distribution, you cannot reject that the probability distribution is coming from normal with mu is equal to 3.5 and standard deviation is equal to 0.7. And how about the p-value? The p-value is the chi-square greater than 3.5, remember, so this is my chi-square random variable, okay? And it's somewhere here, 3.15. And how about the critical value is somewhere here. So this is chi-square with, which gives an area of 0.05 to the right. And the value here to the right of 3.15, okay, which is this dotted region, this is equal to 0.37. This gives the credibility of the null hypothesis, which is high, okay. So you cannot reject the null hypothesis. So what does it mean? The better life may have the normal distribution with mean 3.5 years and standard deviation 0.7.